In the previous lectures, we talked about basic counting principles. And in the basic counting principles, we talked about multiplication and addition principle. And we also talked about permutations with repetition doesn't allow it, with no repetition. We talked about that and we finished it. And now we have if the repetition is allowed. We have our permutation for repetition allowed. Okay, we say if we have for n r permutations of a set n, that means we are gonna choose r things from n things. We are gonna choose r things from n things. Here it equals the permutation of n and r. We say permutation of n and r. As I said, we are going to choose r from n. Okay, it equals n to the power r. In this case, if the repetition is allowed, we say it equals n to the power r. Okay, why? Because we first the first thing from n things, and then we choose that second one from n things, and so on for others. That's why we say it equals n times n times n times up to n. Here we have r times. We multiply n r times by itself, and we get n to the power r. If the repetition is not allowed, when we choose the first thing from n, so we choose the second one from n minus 1. For example, if you want to choose 3 from 5, we say in this case, if we choose 3 from 5, we say it equals 5. The first one we choose from 5 things. We choose 3 things. Then the second one, if the repetition is not allowed, we choose from 4 things because one of them is chosen before for the first one. And then for the third one, we choose from 3. 5 times 4 times 3. This is the results here. This is how to choose or how to r permutations from n, from the set of n things. If the repetition is allowed, is not allowed. This is for a repetition if not allowed. But if the repetition is allowed, for example, if you want to choose 3 from 5 things, we choose the first one from 5 things. Then it's possible to choose the same thing again. That means we choose the second one from 5 again. And then the third one is also 5. That means choosing 3 from 5 is 5 to the power 3. Here, this is the general form. If we choose r from n, that means the permutation of nr equals n to the power r. Here, we take some examples. In the log, there are 10 numbers from 0 to 9. From 0 to 9, here we have 10 numbers to choose from 0 to 9. And you choose 3 of them. If you want to choose 3 from 10, 3 from 10, and if the repetition is allowed, we say we choose the first one out of 10, and then we choose the second one again out of 10, because in the log it's possible if we have all 3 numbers to be the same. For example, 333, 444, and even it's possible if we choose 2 of them to be the same and the other one is different. That means here repetition is allowed. We choose the first one out of 10 numbers, and we choose the second one. It's possible to choose the same number again. That means we choose the second one from 10, and we choose the third one from 10, which is 10 to the power 3, which is 1,000. That means here we have 1,000 permutations. We have 1,000 permutations if we choose 3 from 10. In this example, look, who's gonna tell me how many 5 letters word can be formed from the letters A to Z? From A to Z is 26 words, letters. Okay. What's the permutation if we choose 5 from A to Z, if the repetition is allowed? So we choose the first one out of 26. How about the second one? Again, out of 26, up to 5 times. That means it equals to what? So 26 to the power 5. Yes, 26 to the power 5. It is 26 to the power 5. Why? Because we choose 5 things from 26. We choose the first one and the second one, third one, fourth, and fifth one. All we choose from 26 things. That means it's 26 times 26 times 26 up to 5 times. So you say it equals 26 to the power 5. Here we say the permutation of 26 and 5, the permutation of 26 and 5 is 26 to the power 5. Okay? And here we say if we have n objects and k different types, if we choose n objects from k different types, we say for a collection of n objects of k different types, the total number of different arrangements, here we just need to talk about arrangements in this case, of these n objects is n factorial, dividing by the multiplication of factorial for each type. We are gonna, here if you have, let's say, 6 types, in the denominator here we have the first type factorial times the second type factorial times the third type factorial up to 6 type factorial. Here we have an example. It says find the number of different ways the letters of the word assessment, here you have assessment, can be arranged. Look, how many letters do you have in assessment? It's about arrangement of these letters. The question is about arrangement of these letters. How many letters do we have in assessment? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means here n is 10. Okay, and then we have different types of letters. We have A, we have S, we have E, we have M, N, and T. We have these letters. These are the different types of letters. So how many A do we have? How many A do we have in the word assessment? We have only 1. That means we have only 1 A. How many A's do we have? 4. That means A's 4. How many E do we have? 2. So E 2. How many M do we have? 1. How many N? 1. And T 1. These are the different types. And we want to arrange these 10 words, these 10 letters. We have 10 letters. That means N is 10. What are these A, S, E, M, N, and T? These are N1, N2, up to NK here. We have these. That means we have, we say, in how many ways we can arrange the word assessment. We said equals n factorial dividing by the multiplication of factorial for these types. Okay, it equals 1 factorial, which the number of a is factorial, times 4 factorial times 2 factorial times 1 factorial times 1 factorial times 1 factorial. Here we multiply the factorial of all types in the denominator, and in the numerator we are gonna find the factorial of n. N is the number of letters here. The number of letters here is n, which is 10. So it equals 10 factorial dividing by 1 factorial times 2 factorial times and so on. 1 factorial times 4 factorial times 2 factorial times 1 factorial times 1 factorial times 1 factorial. Let's just finding this. We say 1 factorial is still 1. 4 factorial is 24. Yeah. 2 factorial is 2. 1 factorial is 1. 1, 1. Here we have 1, 24, 2, 1, 1, 1. So the denominator is 1 times 24 is still 24. Times 2 is 48. Times 1 times 1 times 1 is still 48. So the denominator is 48. And the numerator we have 10 factorial. We are going to find 10 factorial dividing by 24. And the result is 75,600. It is 75,600. So here, the most important thing here is to know this rule. I mean this one. If you have different types, if you have different types of n objects, we say we should use this rule. We say it equals n factorial, which is n objects. In the word assessment, we have 10 objects, 10 letters. How many types do we have? Here we have 6 types. We have 6 different types: A, S, E, M, N, T. Okay, we have these 6 different types. We are going to find the number of each type factorial in the denominator. We multiply them all, and in the numerator we have the number of objects factorial, which is n factorial. Okay, it's only calculations. Yeah, it's easy to calculate. We now have permutations of circular arrangements. For the line arrangements, we said to arrangement, let's say 5 people on a line, we said equals 5 factorial. We said that. For example, arranging 5 people on a line, we say it is 5 factorial. Okay? But for circular arrangements, we say to arrangement n people in a circular arrangement, we say it equals n minus 1 factorial. That means we subtract the total number by 1, then we find factorial. For example, if you want to find the arrangement of 5 people, or sitting 5 people around a round table, okay? If you have a table here, let's see. If you want to sit 5 people around this table. In this case, here we have circular arrangement. What رخصني بازني من بازني الركان خين كبازني الركان خين هيبتشي we have here we have 5. That means we say it's 5 minus 1 factorial, which is 4 factorial. That's all. Okay, we just subtract the total number by 1 and then we find its factorial. Here we say there are two cases of circular permutations. If clockwise and anti-clockwise orders, that means if you order clockwise or anti-clockwise, if these two orders are different, then we say we have n minus 1 factorial of the arrangement. But if there is no difference between clockwise order and anti-clockwise order, we say it equals n minus 1 factorial divided by 2 factorial. We divide by 2 factorial in this case. Here we have 4 persons, A, B, C, and D. We name the persons, let's say person 1, person A, person B, person C, and person D. These are sitting around a round table. Here we have a round table. We want to sit 4 people around the table. In how many ways we can do this? In how many ways we can do this? Since that circular arrangement, همون رخصنه که بازنی چند کس چند من هبیه چند کس من هبیه الان ناقص یک فاکتوری. Okay, here we have 4. That means the number of arrangements here is 4 minus 1 factorial, which is 3 factorial and 6. That means here we can arrange 4 people around a round table in 6 ways. Okay. Yes, for the linear, as you see, for the linear one, in the linear arrangement, if we want to arrange 4 people on a linear, on a line, we say we have 4 factorial in this case, which is 24. This 24 ways. If we want to arrange 4 people around a table or on a queue, on the queue, we say we have 24 ways, but on the around table, we say we have 6 ways. Okay, for the around or circular arrangements, we say it's n minus 1 factorial. But for the linear or line arrangements, we say it's n factorial. And we have 4 people. For the line one, we have 4 factorial. But this here, we get 3 factorial, which is 4 minus 1. That's it. Sorry. Okay. Here you have an example. Here it says, suppose you are expecting 10 people for dinner. We have 10 people for dinner. How many ways can we sit? Can you sit them around a circular table? That means here we have a circular table. ميزة بس نیم هي. أما ده نفر اللي صار دابنيش. بچن رجعتوا أنا. Yeah, it's 10 minus 1 factorial. It's n minus 1 because here we have 10 people. That means n is 10. If we want to, I get money. بشوي هي اللي دامبنيم. بشوي كريك. أمان إكسر كهاد ده factorial. It's 10 factorial. For if you want to arrange, if you want to arrange 10 people on a line, but if we want to arrange 10 people in a circular table, on a circular table, I get less than music down بنم جالك الله يبارك فيك باشا بله همان جماعي النفرة سيركن ليرة كاتي كان كاس ليرة كأبيته بأخير أخير هديته جي خوي أو جي ورقته بيشتري هذا حسابني واه بله لا هيك كشن يعني لبر أوي كاتي كتوي كم كاس ليرة كأبي بأخير كاس يتوجي خود او جدول قلت بشكاته او فري وحسابني ونيا او شنو بحسابني كذا تنجد نو جدول كتبوا هاي لدي ما يتوجهوا. Okay, look here we have 10 people and we want to sit these 10 people on a circular table. So how many ways do we have? We said any arrangement on a circular table is n minus 1 factorial. So what's n here? N is 10 people. That means n is 10. With 10 minus 1 factorial, which is 9 factorial, equals to what? 5. Okay? So here we have 9 factorial ways to sit 10 people on a circular table. وتريس كردن لسر ميزك يخر لقال هيلك بشوي رويك دائم نتجاوز. أجا بشوي هيلي دائم أكات n factorial. طبعا أقول لهم سد ميز يخربو أو كات n ناقص factorial. So this is only talking about the solution. It's about the linear arrangement. But for the circular arrangement, we say it's n minus 1 factorial. So here we have 10 minus 9 factorial, which is 9 factorial. Just find this, that's all. This is the end of this part of chapter, part 2 of chapter 3. So it's the end of permutations, not the end of the part of the chapter. We now have combinations. So what did we talk about up to now? We talked about counting principles. In counting principles, we have two ways: addition principle and multiplication principle. And we also talked about permutations. In permutations, we have two ways. One of them, if we have no repetition, if repetition allowed. But for permutation, we said we care about ordering. Okay? We care about ordering for permutations. But for combination, we don't care about ordering the choices. Okay? So now we have combinations. In combinations, we have two ways: if we have repetition and if we have no repetition. Okay? We have two, we talked about permutations before, and now we say the order doesn't matter now. That means ordering of the members of the elements doesn't matter here in combination. But for permutation, it was matter. Okay? It's matter for permutation. But for combination, we say the order doesn't matter. There are two types of combinations. We say if repetition allowed and if we have no repetition. We have these two type of combinations. An example for repetition allowed, for example, such as coins in your pockets. 5 cents, 5 cents, 5 cents, 10, 10 cents. May someone has 3 5 cents and 2 10 cents in his or her pocket. In this case, as you see, we have repeated coins. In this case, repetition is allowed. The repetition is allowed. But for example, for enrolling the subjects, is any student can enroll a subject twice? No. No student can enroll a subject twice. Here, maths, English, music, and so on. No one can choose math twice, or English twice, or more. That means it must be once. Okay, the subjects must be once. That's why here, in this case, we say this is an example with no repetition. So with no repetition, but in the above one, repetition is allowed. It's okay if someone has 10 5,000 in his pocket. Okay. And also for the repetition one, we can take another example for your mobile phone's password. It may all the numbers the same. May some of them are the same, some of them are different. May someone put 3 zeros and 3 ones for the password of his phone. This is for his phone, his mobile phone. Okay. Here, in this case, repetition is allowed. That's an example for allowing repetitions. Here, if we have the set X to be X1 up to Xn, containing n distinct elements. Here we have a set which contains n distinct elements. We say, and R combinations of X, and R combinations of X is an ordered. We don't care about ordering here, but for permutations, we care about it. Selection of R element of X. Here, if we want to choose R element from n elements without caring about ordering. If we don't care about ordering, in this case, we must use combination. Here, we say C and R. C and R. It equals to what? Here, this is the rule. The rule is n factorial dividing by R factorial times n minus R factorial. Who's remembered? Who's remember P and R? What's the rule here? The rule for permutation is n factorial divided by n minus R factorial. Is it? It's n factorial divided by n minus R factorial. This is for permutation. Just to remind you this rule. But for combination, it's the same as permutation, but it's divided by R factorial. These two are similar, but here we just divide it by R factorial. This is the difference between these two rules, this and this one. Between permutation and combination, here we just have R factorial for combinations. The rest is the same. As you see here, if you have not this one or there, we just have permutation. Okay? So the difference between these two rules, this is just to make a relation between these two. If you just memorize one of them, you can write down the other one based on the other one. Based on the one is memorized here. If you just memorize the permutation, divide permutation by R factorial, you get combination. Okay. This is the rule for combination. So the rule of combination C and R, that means choosing R things from N things, is N factorial dividing by R factorial multiplying by N minus R factorial. Okay, this is the rule. Let's back to our pool ball example. Let's say that you just want to know which 3 pool balls were chosen. Not the order. If we don't care the order and you want to pick 3 balls from 16 balls, what we get? We get C 16 3 in this case. If we don't care about the order of the choose balls, we say it is C 16 and 3. We use combination in this case because we don't care about ordering. So it equals 16 factorial dividing by 3 factorial. R here is 3. We just replace N and R by their values. 3 factorials times N minus R, which is 16 minus 3 factorial. And this equals to 16 factorial. This equals to 16 factorial dividing by 3 factorial times 13 factorial. Okay, and equals to times. But yes, here we can cancel out these, so you get only 16 times 15 times 14. Okay, and 3 factorial is 6. No, here, look, 3 factorial times 13 factorial doesn't equal to 16 factorial. These are not equal because if you expand this, this becomes 13 times 12 times 11 times up to 1. And this equals to 3 times 2 times 1. But 16 factorial equals 16 times 15 times 14 up to 1. Okay, that's why we cannot say that. Here, to simplify this, we get, let me write down clear. We say C 16 and 3 equals 16 factorial means it is 16 times 15 times 14 times 13 factorial. Is it? We talked about this at the beginning of this chapter. And in the denominator we have 3 times 2 times 13 factorial. 13 factorial and 13 factorial are constant. 3 with 15 becomes 5 here. And 2 with 16 is 8. 8 times 5. 8 times 5 is 14. Times 14, you get that. Okay? So it's just multiplying this, do it by yourself. Here, for the permutations, we say it is 15 times 14 times 16. If we choose 3 balls, from 16 balls, in this case, we say this 16 times 15 times 14 is for permutation. If we care about ordering. If you care about ordering. But if we don't care about ordering, we say we divide this by 3 factorial. Okay? For example, here, if we choose 3, let's say we choose balls 1, 2, and 3. Okay? For permutations, if we care about ordering, we say we may pick the first ball to be 1, the second ball to be 2. If we choose the first one to be 1, the second ball to be 2, and the third one to be the third ball to be 3, and may someone else choose the first one to be the first ball, ball 1, the second to be ball 3, as you see, it's different from the above one. This order is different from the above, and also this ordering is different from the above ones. This one is also different from the above. Each of these are different from the above ones. That's why here, if we care about ordering, that's the permutation. But if the ordering doesn't matter, we say it's 1, 2, 3, 3 balls. We don't care which one is first. Okay, which ball is first? We don't care about that. But for permutations, we care about which ball is the first one, what's the second one, what's the third one. In this case here, we have these types. As you see here, for choosing 3 balls out of 16 balls, if the order does matter, we say we will have 6 times as many possibilities. This is for permutations. But for combination, one has only 1. We just guess 3. We just pick 3. We don't care which of the 3 balls is the first one. ليرة تنحاس سيانها سير كلا permutation combination. Permutation شيء. قريمة على سيبر هوجو. أم سيان قريمة نفرق. إيش يلا بشيء. Sorry. So the difference of them is 6. Yeah, in choosing 3 balls out of 16 balls, for permutation, we just say 16 times 15 times 40. But for combination, we say we divide the result by 3 factorial. We divide it by 3 factorial. So here we say n factorial dividing by permutation divided by r factorial. So r factorial is the chosen ones. We divide by r factorial. So here, say our pool ball example, now without ordering, we say 16 factorial. If we don't care about ordering, we use combination. That means we have C, 16 and 3. It equals 16 factorial dividing by 3 factorial times 16 minus 13 minus 30 factorial. So you get 516. We also can use this way to get the result. In both cases, you get the same result. Yes. So let's take a break for 10 minutes. So we finished this example. We now have another example. It says, in how many ways can you select a committee of 3, a committee of 3 from a group of 10 distinct persons? Here we have 10 persons, 10 people. From these people, we want to make a committee. In the committee, it's not mentioned to choose the, let's say, the chairpersons, the secretary, and anything else. It's not mentioned that. That means ordering is not important. It's not important to choose one of them first. Okay, we just make a committee from 10 persons. Make a committee of 3 from 10 persons, 10 people. That means here ordering is not important. Ordering is not important. So in this case, what do we use? Do we use permutation or combination? Which one? We use combination. Here, in this case, we use combination because ordering is not important here. It's not mentioned that to choose chairperson, secretary, or anyone else. It's only said that choose 3 from 10. Or it's making a group of 3 from 10 people. In this case, we use the combination. So the combination of 10 and 3. We select 3 people from 10 people to make a committee of 3. It equals. It's not given that choose secretary, choose chairperson, choose treasurer, or anyone else. In this case, what do we use? We use combination because there is no ordering. Ordering is not important here. We say it's 10, it's n factorial, it's 10 factorial, dividing by. So the combination of n and r is n factorial, dividing by r factorial times n minus r factorial. So here we say C of 10 and 3 is 10 factorial, dividing by 3 factorial, multiplying by 10 minus 3 factorial equals 10 factorial, dividing by 3 factorial, multiplying by 7 factorial. Okay, we now expand the numerator, because 10 factorial becomes 10 factorial becomes 10 times 9 times 8 times 7 factorial. These two are cancel out. Okay, and here we have 3 factorial, which 3 times 2. 3 with 9 are cancel out, and here we get 3. But so this is not recorded actually. Let me do it again because I haven't recorded this one. We say we have this example. In the example, it says, in how many ways can you select a committee of 3 from a group of 10 distinct persons? We have 10 persons. From these 10 persons, we want to make a group, or we want to make a committee of 3. It's not mentioned that here who is the chairperson, which one is the chairperson, which one is the secretary, and which one is the treasurer. And here, ordering the members of the committee is not important here. That means, in this case, we can use combinations. But if it's mentioned that to choose secretary, chairperson, and the treasurer, in that case, we must use permutation. But here, as it's not mentioned that, we can use combinations. For the combinations, we say we can use combination if the ordering is not important. Here, the ordering is not important. We have 10 people, and we want to make a group or a committee from these 10 people of 3. If we want to make a committee of 3 here, it equals, we say, this equals to what? We have C 10 and 3. It equals 10 factorial dividing by 3 factorial times 10 minus 3 factorial. So this equals to 10 factorial dividing by 3 factorial times 7 factorial. We now expand the numerator. To expand the numerator, we get, let me clean this one here. This equals 10 times 9 times 8 times 7 factorial until the highest factorial in the denominator. We just expand it till we get the highest factorial in the denominator. In the denominator, we have 7 factorial as the highest factorial. So we just expand the numerator till we get 7 factorial. Now we have 3 factorial times 7 factorial. And these two are cancelled out. So what's left? In the numerator, we have only 10 times 9 times 8. In the denominator, we have 3 factorial. And 3 factorial could be 3 times 2. 3 with 9 are cancelled out. We get 3 here. And 2 with 10 are cancelled out. We get 5 here. 5 times 3 is 8. 8 times sorry, is 15. This is 15. And here we have 8 also. 15 times 8 is 120. That means we can make a committee of 3 out of 10 people in 120 ways. Okay? We now have another example. It says, in how many ways can you select a committee of 2 women and 3 men from a group of 5 distinct women and 6 distinct men? Now we have 2 groups. From these 2 groups, we want to make a committee. We have 2 groups, group of women and group of men. Women. And here we have men group. In the women group, we have 5 distinct women. In the men, we have 6 distinct men. From these 2, we want to make a committee of 3 men and 2 women, 2 women and 3 men. We want to make this group. Okay. How to make this? In how many ways we can make this group? Look here, we choose 2 from 5 women, and we choose 3 from 6 men. And here ordering is not important. Ordering is not important. That means we use combinations here. We use combinations. Here, from the women, we take 2. From the men group, we take 3. That means here we have combination 3 of 6 and combination 2 of 5. That means we say to select 2 women from 5 women, it equals C 5 and 2. It's C 5 and 2, which is 5 factorial dividing by 2 factorial, 3 factorial. Okay, how to get this? We say C 5 and 2 equals, this equals to 5 factorial divided by 2 factorial times 5 minus 2 factorial. 5 minus 2 factorial is 3 factorial. So you get 5 factorial dividing by 2 factorial times 3 factorial. That's it. Just expand the factorial so you get that the result is 10. That means if we want to select 2 women from 5 women, we can do it in 10 ways. We can do it in 10 ways. And to select 3 men from 6 men, it is C 6 and 3. It equals 6 factorial dividing by 3 factorial times 6 minus 3 factorial. It equals to 6 factorial dividing by 3 factorial, 3 factorial. Simplifying this, expanding the factorials and cancelling out numerator and denominator, we get that 20. That means we can select 3 men from 6 men in 20 ways. In 20 ways. Now we have 10 ways for selecting 2 women and 20 ways for selecting 20 men. We just multiply them, we get the results. Multiplying these 2, we get 200 ways. That means both together, I've been choosing 2 women and 3 men out of 5 women and 6 women. We can do it in 200 ways. That means we have 200 ways for selecting a committee of 2 women and 3 men. Okay? Do you get that? Who has a question about this? We now have another example. It says, how many 8-bit strings contain exactly 4 ones? In strings, if we have 8-bit strings, that means we have 8, 0, or 1. 1, 2, 3, 4, 5, 6, 7, 8. we have 8 numbers, and each is either 1 or 0. It's either 1 or 0. And here it says in how many ways we can create 8-bit strings to contain exactly 4 ones. That means we have 4 from 8. We have 4 from 8. That means in how many ways we can write down 4 ones here. 4 of them, only 4 of them. Let's say you have these 4. If you have only these 4, we have these 2 and these 2. We may also have these 3 and that one. We may also have these 2 and these 2. It's like that. That means in how many ways we can write down 4 ones in 8 spaces, okay, without ordering. If ordering is not important. So if the ordering is not important, we say we use combinations. That means here we have 8 spaces. We want to write down 4 ones in 8 spaces. That means we say it's combination of 8 and 4. It equals to 8 factorial divided by 4 factorial times 8 minus 4 factorial. We just apply the rule here. The rule is n factorial divided by r factorial times n minus r factorial. And here n is 8 and r is 4. So this equals to 8 factorial divided by 4 factorial times 4 factorial. This equals to 8 times 7 times 6 times 5 times 4 factorial, dividing by 4 times 3 times 2 times 1 times 4 factorial. These two are cancelled out. We have 4 factorials in both numerator and denominator. We have 4 factorials in both numerator and denominator. These two are cancelled out. And here we have 8 and 4 and 2. These two are cancelled out. Here we have 3 with 6 are cancelled out. You get 2. So 7 times 2 is 14. Times 5 is 70. We get 70 ways. That means we can have 8-bit strings in 70 ways, where 4 of them are ones. Where 4 of them are ones. So here we say we have 70 ways to do this, to select or to write down an 8-bit string if it has 4 ones. Do you have any question about that? Here we have 8 spaces. We want to fill them, 4 of them, only 4 of them by ones. Okay, we have 8 spaces. We want to fill only 4 of them by ones. That means we find combination of 8 and 4, because here we have 8 spaces and 4 ones. Since the ordering is not important, that means here we use combinations. Okay, do this and tell me how do you get that result. With your partners, try to do this. With your partner, try to do it. Here we want to make a committee. The committee is 6 people. We want to make a committee of 6 people. We want to create that committee. We don't work on it. Where do we work? We have 8 lecturers and 4 students. From 8 students, it says in the committee contains exactly 3 students. That means we choose 3 from the students. So how many more members do you need for the committee? Three more, because our committee is 6 people, contains 6 people. 3 of them are students, it's given that. So how many more do we need? 3 more. So we just need to take 3 more from the lectures. That means we choose 3 from 4 without ordering. That means in this case we use combination. The combination of 4 and 3, it equals 4 factorial dividing by 3 factorial times 4 minus 1 minus 3 factorial. It equals to 4 factorial dividing by 3 factorial times 1 factorial. It equals to 4. Okay, this equals 4. Then we choose 3 from 8 lectures. That means we find the combination of 8 and 3. It equals to 8 factorial dividing by 3 factorial times 8 minus 3 factorial. This equals to 8 factorial dividing by 3 factorial times 5 factorial. It equals 56. It is 56. We now multiply these two results. Look, from this way, look, to choose 3 from 8, here we have 56 ways. In this direction, we can choose 56 people, we can choose 3 students, 3 lecturers in 56 ways. And in how many ways you can choose 3 students? 4 and 56 ways. We multiply them to get the total way. Okay, we multiply these two. So the total way, so the number of ways to create a committee of 6, such that 3 of them are exactly, 3 of them are students. We say here we have 4 times 56. That's 224. We have 224 ways to make a committee of 6 people if exactly 3 of them are students. Okay. And here you have the second part of the example. It says, if the committee contains at least 3 students. Look, here you have some cases. We have 8 lecturers and 4 students. We say at least 3 of them, to be students. That means here, so let's say, is the number of students could be 3? Yeah, we can. Yeah, it could be 3. So how many more people do you need to create the committee? Cerca, se mai la student che ho già, c'è ne che pensa perché c'è che si fa. 3 more. اینجا على چی؟ على بلانی که موسیقی کردی. اکرد شو کن کردی یابی؟ بله. So if the number of students is 4, how many lecturers should we choose? 2. Okay. Now we are going to find 3 out of 4 multiplying by 3 out of 8. Then 4 out of 4 multiplying by 2 out of 8. كده اتوانك تنفي خن كاركان لا لبري كوي هم شنو شوار ناتوان زياده بلا شوار ناتوان زياده شوار خن كارل بشي كادي كاله بلاني كموسيقين كاتا اكل سيبي اكل شوار اكل بينز بين نخل هو لبري جمال خن كاركان شوار اي جمال خن كاركان شش بوا اكل بينز بوا اكل شش بوا شنو ما ابو ليكشر كمان كوات ليره سوره كان بيكو Okay, here we have combinations of 4, 3. Let me do it in red color. We have combination of 4, 3 times combination of 8, 3. We found this. This is 224. We found this before in the first part. And now we have the combination of 4 times combination of 8 2, it equals to 4 is 4 factorial dividing by 4 factorial times 0 factorial. Is it? 0 factorial is 1. As I said before in the previous lecture, we said 0 factorial is 1. That means we just write down 1 here. It is 1. Is it? We get 1 here. And for the combination of 8 and 2, it's times 8 and 2, it's 8 factorial, dividing by 2 factorial times 6 factorial. That's 28. That's 6 factorial, yeah, that's 28. It's 4 times 7, which is 28. Here we get 28. Multiplying these two, it's 1. It equals to 1 times 28, which is 28. So in this case, we get 28. And in the previous case, we got 224. We add there, we get that. Okay? So that's it. It's the second part. Here, we get 28, and here we got 224. We just add these two. We get the result. It's 252. ليه مو أمان زايدنا فعملكاتك أويت المالك دانك combination سيبو شوال سيبو مشكلة دانك والله دو أنجام كان كوكين أما دو هنجاي جواز دو سيبي جواز دو يجت بويكانك والله أقول له همان سيبك لهمان سيب على سيلة ما بجرب سيلة وش لهمان سيب أملك دانك والله أنجام لأنه أنجام سيبي جديد okay. So here we found the combination of 4 times 8 3, which is 224. We also found the combination of 4 and 8 2, which is 28. We add these two, we get the result, which is 252. This is the result. Okay, and so it's enough for today. It's time's up.